Hello students, greetings of the day. This is your NE Rao, faculty in physics, come director VIP classes. Today we'll talk about atomic physics. Okay.
See, early 19th century, okay, so many experiments were actually conducted in order to understand, okay, behavior of gases you can take or try to know the structure of an atom. Okay, so many experiments were done. So basically, experiments conducted in discharge tube by like scientists names like J.J. Thomson, you can say, okay, Rutherford, you can say, okay, Bohr, Niels Bohr, you can say, okay, all these scientists, okay, mainly focus was done by this J.J. Thomson scientist. So when he has conducted this discharge tube experiments, no, he discovered electrons. Okay, so electrons are what? Stream of what? Electrons are negatively charged particles, and we understand the properties of negatively charged particles called cathode rays, okay, and how they are emitted, and when they are striking the surface of the glass, different colors were seen, okay, all those things, okay, in the Coolidge tube experiments you have seen. Then he applied electron for the flow of electrons, he applied magnetic field, electric field, so he can accelerate the electron by creating some potential difference. Okay, so positive potential here, negative here. So the electron gun is there. The electrons emitted from here. The electron particle is going here. To increase the velocity, to accelerate them. Then positive plate, you can apply positive potential here, isn't it? So it accelerates. So when it is accelerating, the kinetic energy is increasing. Who is doing the work? Who is doing the work? So an electron gun. So the electrons are emitted here. So what you can say is this is by emission of electrons from negative plates. So high tension battery utilization में electrons may emit by thermionic emission. So when your becomes red hot and electrons are emitted by thermionic emission. The phenomenon of emission of electron by heating effect is called what? Thermionic emission. We have three types of emission. One is called field emission, thermionic emission, photo emission. Photo emission is the photoelectric effect. Thermionic emission by heating coil, and field emission is applying large amount of field to cut out the electrons to the outermost orbits of the what? Atoms and all. Therefore, here electron can have some degree. ఏమవుతుందంటే రెండు రకాలు విన్నాను మనం ఏం చేయొచ్చు ఇక్కడ సో దీనికి మనము బిహైండ్ ది హీటింగ్ కాయిల్ పెట్టేసి ఇలా బికాజ్ ఆఫ్ దిస్ హీట్ రేడియేషన్ అండ్ ప్లేట్ న్యూక్లియస్ కోడి from this metal plate electrons. So now, so this plate and when these electrons are emitted here, so we can create a positive. So this will be related to particular element of two kind of structure. This is called, you can say, a discharge tube, we can say, or somewhere when gases are here, here, fast moving electrons they collide with the gases. Okay, so in all these kind of experiments, J.J. Thomson has done, and during this process only he discovered what? Electron, J.J. Thomson. Okay, now when this electron is moving, the question here, what type of question will be asked here? So who is doing work in accelerating this particular charge particles? The charge particle is Q. Of course, the electron charge is P. Nature is negative charge particle. So who is doing work? Potential difference is created here. So V is equal to V is the potential difference. So this electric field is doing work in accelerating charge particle. So potential is by definition of potential or potential difference work done per unit charge. So how much amount of work you are doing? That is equal to 2 into V is the work done. So in accelerating the charged particle. So charge of the electron is E into V is the work done, and this work done by electric electron is E into V.
This work done will appear as kinetic energy of the electrons. Okay.
Okay, so here velocity of the electron, velocity of the fast moving electron will be how much now? Root of 2 into V by m. 2 E by m. Sometimes the electron holding a net at 2 E by m. This is what velocity of the electron. But momentum of electron will be momentum, kinetic energy. Kinetic energy is E into V. This kinetic energy, no. Momentum means what? M into V. You can take m inside. So the momentum of the electron will be m into V. Now, already I discussed the moving charges magnetism. This kind of fast moving electrons, when they enter the magnetic field, they will experience what? Magnetic force perpendicular because they trace a circular path and radius a circle. So this kind of liquid questions will be asked. Keep in mind. Therefore, this P is M into V. So M into V means C root of 2E by M, and this force inside. M square will get cancelled. This is equal to root of 2M into E. This is momentum of this what? Electrons over here. Now applications, what kind of applications will be asked here? So when they enter its fast moving electrons will enter a magnetic field, say pointing into. If it is positive charge, Okay, its velocity if it is like this, V cross V, magnetic force was upward. Because if you have attention upward circle like this. But negative charge no what happens? So it is entering the experiences force, it places what? Circular path in the magnetic field. Then if radius already we have seen, time period we have seen the radius equal mg by bq. And you will say momentum by bq. Substitute the value of momentum here, how much? Root of 2 mv by bq here. Therefore, the radius of circular path magnetic field is how much, right? Root of 2 m into b divided by what? bq or b3. If you simplify this one, what we have here? This is equal to 2 m b. Okay. Divided by this is 1 by b. Root under root of 2. Anyway you can say simplification. Okay, this kind of liquid application they are asking, so keep in mind. So accelerating charged particles, and one more velocity sector also we have seen. So when they are moving like this, magnetic field is switched on. Thomson what he did, no, he applied both electric field is applied, see positive negative direction of electric field is like this. Magnetic field is pointed inward. Magnetic field is pointed inward. If it is positive charge, if it is positive charge, B cross B, force was upward. But this negative charge, force will be what? Force will be downward. So this fast moving electrons, they will go and strike here, and it will create some screen. Okay, zinc sulfate screen kind of thing. You after the scintillation sign off. Okay, so here electron is going to experience magnetic force. So he adjusts the value of field such that the electron goes without any deviation. And what is the formula we are saying? So electric force is like this, E into E. Magnetic force is what? Perpendicular to the electric field down. Magnetic field will be downward, isn't it? So he adjusted such a way that electric and magnetic fields are balanced or perpendicular to the flow. One more electric field applied in positive plate, here negative plate. So this electrons experiences upward force like this. Magnetic field is here downwards, and this field is for accelerating. Okay, this is called transverse magnetic field is created. When these two equal, it goes with constant velocity and strikes this particular target. Okay, same is the principle during the generation of X-rays also we have seen Coolidge tube. Fast moving electrons when it hit a metal target, what happens? X-rays are produced. Characteristics X-ray we have seen, smooth X-rays, hard X-rays we have seen. Same principle here. So you can say E into E is equal to B into E. So E. So E get cancelled. So velocity which will strike the target is equal to E by B. So from the ratio of these two, you can find the velocity. You can calculate the kinetic energy. What is the formula for kinetic energy in this case then? Kinetic energy is half m v square. V square means E square by V square. This is also important formula. And then what you have seen, so about after this now discovery of electrons, and as a whole they have observed that as a whole the atom is neutral. Okay, and discovery of electron already happened. So inside the atom we have the electrons. Then as a whole when the atom is exhibiting neutral, okay, charge here. So one positive charge must be there. If positive charge is there, how positive and negative charge arrangement is there? Okay, then the different proposals have been come. So how come up? So in the 19th century, then the first scientist J.J. Thomson only who discovered the electron. He said, yes, atom as a whole is neutral. No, I found the electrons. Electrons is such that they're like watermelon structure. No, atom is spherical. You can say inside the red portion is there. No, it will act like a positive charge, and the black six will act like what? Negative charge. And both positive and negative equal. The electrons are embedded like the seeds in watermelon. Okay, so of course he could able to explain somehow the other the neutrality of the atom, but could not explain other such phenomena, because of which Thomson model got failed. And then next scientist who was doing experiments with alpha scattering experiment. Okay, so he actually already Rutherford came into picture. Rutherford said no, so the model cannot be like this. The stability of the atom, okay, was not explained here. So here he just mentioned neutral, or yeah, positive charge, neutral only mentioned, but other physical phenomena which are happening was not able to explain by Thomson model. Then Rutherford came into picture. We know very well Rutherford alpha scattering experiment. So we have what have done. So source of alpha particles, radioactive material you can take are some source of alpha particles. So is placed over here. So stream of alpha particles are bombarded over a small thin gold file. Isn't it? Fine. So we have seen a simulation for purpose of observing zinc sulfide speed kind of thing is given here. Right, these alpha particles are targeted toward a thin, okay, gold foil or some thickness T over here. Then he observed that the deviations, if collision to takes place, always the physical contact did not be required here. Okay, so this is an example where for collision physical contact is not required. Same of the alpha particles have which charge? A positive charge of magnitude 2 units to electron charge. Because helium plus 2 nucleus is called what? We remove 2 electrons from the helium 2, helium 4. The entity formed is called what? The entity formed is called what? Helium is called what? Alpha particle. We remove 2 electrons from this helium 2, helium 4. The helium nucleus itself is called what? Alpha particle. So these positive charge particles, we are going to observe that they are deviating from their paths, isn't it? So he observed that most of the particles they are going and they are deflecting to different angles over here like this. Some of them are directly going straight like this. So some other particles to different angles they are scattering here. So the angle through which they are got deviated is called angle of scattering. Here, number of scattered particles which are scattered through angle theta. Okay, if you see other, so so few are directly what? So few are directly like transmitting here. So from these observations, when we take number of scattered particles, okay, scattered to different angles if we consider. Okay, if we draw the graph, number of scattered particles to the scattering angle theta. So as value of theta increases, scattered particle value what is happening here now? Is decreasing. Value of theta is increasing. मतलब क्या है? Lesser number. Value of theta is increasing. No, lesser number of particles are scattered. So for smaller values of theta, large number of particles are scattered. For large angle scattering, lesser number of particles are scattered. That means so the angle through which they are going on deviation is more like this. Okay, if this angle of deviation is more, then the scattered particles scattered through this angle will be less. Scattering angle is less, more number of particles. So more number of particles are coming this side for lesser angle of scattering. This angle is very small. This kind of alpha particles are more here. So in lesser angle, more what? In lesser angle, more number of scattered particles are there. More scattered through more angle, lesser number of scattered particles are there. That means, so from this we understand that so most of the alpha particles they are penetrating and entering outside, passing here, and very few are what? Very few are scattered. And then he defined one parameter called impact parameter. What is impact parameter? Yes. So your number of scattered particles, he observed that they are what? Number of scattered particles scattering through any angle of pole if you consider particular pole angle, any number of scattered particles which is not like that. So within this particular pole, okay. So different angles will be discussed. There particular pole angle will be discussed. How many number of scattered particles are here? The number of scattered particles is given by 1 by sin to the power of 4 theta by 2. 1 by what? Inverse relation with what? Angle of scattering. More is the angle of scattering, lesser is the number of scattered particles. Lesser is the number. This is the graph, the relation he has given. So number of scattered particles to any angle theta is inversely proportional to 1 by sin to the power of 4 theta by 2. So based on this, one exam question is asked there. Okay, we'll do one question also based on this. Okay, write on the question. Then we'll conclude then. Okay. So first, now this is what number of scattered particles. Then I will do after finishing this. Okay. Now one more point I mentioned is here impact parameter. What is impact parameter? Can you tell what is impact parameter? Important for both point of view definition. So here is like this alpha particles which are coming in straight like this and bouncing back in the same direction. For them, angle of scattering is 180 degrees. So they are coming like this straight, again they are repelling back in the same direction. They are retracing the path. Alpha particle is recharged, positive charge. So unless some positive charge is somewhere else here, they will not be repelled. So from this he concluded that very few, so 1 in 8,000 alpha particles are just they are retracing exactly back. Therefore, so here. So when this is when this is the size nucleus actually no. So nucleus is over here now as alpha particles are coming in the bombard here like this. Okay. So what is perpendicular distance from the center to this direction of velocity here? See, the alpha particle is coming like this. Line of velocity is like this. Direction of velocity. So for the direction of velocity, if I draw a perpendicular line, this particular perpendicular distance is defined as impact parameter. The perpendicular distance drawn from center of the nucleus to direction of velocity of alpha particle is defined as what? Impact parameter. And for the particles which are hitting straight path and coming bouncing back through angle of scattering 180 degrees. Okay, what is the impact parameter value? P is equal to 0. And here smaller is the impact parameter. Smaller is the impact parameter. This closer, alpha particles coming closer to this nucleus. Closer to the nucleus. So what happens now? They scatter to larger angle. They scatter to what? Larger angle. And scatter to larger angle. And moreover, larger is the distance. They are far off. They simply go. So they are away from this nucleus. They simply go. And sometimes diagram also important. The path. So this cannot be diagram. Why? Alpha particle and path which are attracted, right? This kind of path if you mention the diagram is wrong. So always they should what? Deviate, should repel back. So sometimes paths also given in the exam. So keep in mind the path also. So path should be such that it should be a repulsive path, not the attractive path. Right. And the impact parameter of Z2 E square. Okay, Z1 is the what? Atomic number of this alpha particle. Z2 is atomic number of this nucleus of this particular what? Atom. Not K. Into cot theta by 2 is given. Impact parameter. So perpendicular distance is more for what? If angle is large, theta is large, cot theta will be larger small. Tan value what happens when theta increases? Tan 90 is infinity, isn't it? So cot value will be tends to 0. Okay, so here now the relation between impact parameter and this particular value, what is given here? V is equal to Z1 Z2 E square by 8 pi epsilon K. Then K you can call as kinetic energy of the alpha particles. K is what? Kinetic energy of the alpha particles, and this is cos by theta is called angle of scattering. This relation is given. And moreover, see if I take V is equal to 0, cot theta by 2 is equal to 0. Cot theta by 2 is equal to 0, 1 by infinity I can write now. Yes or no? If I write V is equal to 0 here, so impact parameter is 0, cot theta by 2 is equal to 0. So tan theta by 2 is equal to how much, right? Tan theta is infinity. So tan infinity for what value? 90 degrees. So theta by 2 is 90. So theta how much I will get? 180 degrees. So impact parameter is 0 for angle of scattering how much? 180 degrees. Means the light is not like this. Alpha particles are going straight. They will bouncing back. Then the angle of scattering is 180 degrees, and they are going in line with the nucleus. Perpendicular distance to direction of velocity is 0. So the straight they are directly colliding head-on collision with the nucleus. And they are what is happening when they are approaching here and they are bouncing back. So here one more parameter they will ask: closest distance of approach. Okay, what is closest distance of approach here? Keep in mind that number of scattered particles scattered to any angle is inversely proportional to 1 by sin power 4 theta by 2. Impact parameter is proportional to cot theta by 2, where Z1, Z2 is the atomic number of this helium, Z2 is the target element here, gold, approximately 79 gold atomic number. So 8 by K is the kinetic energy of the order of 7.8 million electron volt. Energy, high energy alpha particles are bombarded towards nucleus. Nearly 7.8 to 8 million electron volt energy. Okay, keep in mind. So now, if we calculate here, so this B is equal to 0 means angle of scattering coming as 180. Now, when they are approaching like this, one more point is here minimum distance, which is closest distance of approach. Very important here also they are asking question. Right? Now, what is closest distance of approach is important. So, what is closest distance of approach? If all of you can anyone tell, what is closest distance of approach? Right? Yes, everyone. What is closest distance of approach? Meaning itself indicates closest distance of approach. Name Japanese. Closest distance of approach and
maximum distance an electron can move to the nucleus.
Pardon? Closer distance?
Maximum closest distance that an electron to go near the nucleus.
Maximum closer. Okay, how much distance it can approach to the nucleus, isn't it? The distances from the nucleus is called what? Closer distance of
Closest distance of approach.
Again, if I have a nucleus, Okay, as you have seen from this alpha scattering experiment, Rutherford concluded that from this profile graph of this scattering and number of scattered particle impact parameter, he concluded that central portion of the atom is got a heavy bulk mass with positive charge. Then only they will be bouncing back positive particles, and as maximum particles are going like this now away with lesser scattering angles because there is no repulsion force, only centered concentrated at the center. So remaining space they are simply going undeviated, means he expected that most of the portion of the atom might be empty. Okay, so large empty space is there. Okay, if you imagine this entire room as atom and a small pinhead as nucleus, that was large amount of space is there, and the small pinhead size is what nucleus is there. Okay, the as I mentioned, now most of the portion of the atom is what empty space. Heavy bulk part is what having positive charges concentrated at the center, that he is calling as nucleus. And from this closer distance of approach, we can estimate the size of the nucleus. Okay, and from because of which he actually say size of the nucleus, and he could able to identify some heavy bulk part which they are nowadays calling as nucleus. No, Rutherford is given credit of discovery of the what? Credit of discovery of what? Nucleus. Okay, so now when these alpha particles are bombarding here, B is equal to 0 impact parameter. They are approaching here. So what is happening? Because a strong repulsion force of this particular what? The nucleus electric field. So they will be bombarding what? They will almost approximately deviating like this. So theta angle of scattering is 180 degrees. So momentarily when they approach, okay, from this center portion of this nucleus a particular distance, their kinetic energy becoming 0 here. Fast moving, their kinetic energy of the order of 7.8 electron volt high kinetic energy particles. When they bombard, momentarily their kinetic energy becoming 0. So at a particular distance from this nucleus, this distance up to where they can approach close to the nucleus is called closest distance of approach. Now by energy conservation, if I consider, so here fast moving electron kinetic energy becomes 0. Where the energy is going? The energy is stored in this particular alpha particle and this nucleus system together as potential energy. By conservation of energy, this fast moving electrons kinetic energy converts to potential energy of alpha particle and nucleus. Alpha particle and what? Nucleus. Therefore, if I write this kinetic energy as some K here, potential energy formula for two charged particle system is put a number Z1, this is Z2, is charge of alpha particle is Z2E, nucleus charge is Z2 into E, you can say. Yes or no? Therefore, half 1 by 4 by epsilon naught Q1 Q2. Q1 is 2E, Q2 is what? Z into E, Q1 into the R square. R square is distance here. D is called closest distance of approach. Now, this D will be R, D square will be is equal to D square will be equal to how much? 2Z E square by 4 by epsilon naught into time. So if you consider this B value, this becomes how much? Oh, I'm sorry. 1 by 4 by Q1 by R only. Force value. Potential energy only R also. Force only get R square will get. 1 by 4 by Q1 by R. Don't do this mistake like me. Therefore, so D value will be how much now? 2Z E square by 4 by epsilon kinetic energy. Now here the question will be based on closer distance of approach and kinetic energy. Higher is the kinetic energy of this particular alpha particles. More is the distance they can approach. So what? More they can come closer to the what? Nucleus covered this distance will be smaller. So higher is the kinetic energy, lesser is the closer distance of approach. Lesser is the kinetic energy, larger is the distance. So at somewhere else there is energy becomes 0. Kinetic energy becomes 0. So based on this, sometimes they will compare. So kinetic energy given they are coming close to some value. If they increase the kinetic energy or the new closer distance of approach. So D proportional to 1 by K, D2 by D1 is equal to K1 by K2. You can simplify this. Or sometimes they will compare for two nuclei also. They will take into picture this one. So closer distance of approach is proportional to what? Z by kinetic energy. So based on this question of asking they are, so keep in mind here. Okay, and conversion of energy. The minimum distance from the nucleus at which the momentary kinetic energy becomes 0 is called closer distance of approach. Okay, here questions they are asking. So based on this relation, keep in mind. Yeah. Next, this is about what alpha ray scattering experiment, and from this what? Okay, so from this experiment he concluded that yes, atom has got large empty space at the center portion, bulk positive charge is there. And he mentioned that Rutherford, yeah, as a whole, atom is neutral, no? So electrons are revolving around the nucleus like planets are revolving around the sun. That's why the Rutherford planetary model you can say. But what are the limitations of Rutherford model? Yeah, can anyone tell the limitations of Rutherford model? Yeah, they will lose energy. Why they will lose energy? Huh? What is classical model? Why they lose energy? They lose the
Physics of an atom.
they lose energy. Why they lose energy, right? Yeah, they will fall, but why? Why so? Why they have to actually? Right. Fine, fine. Listen over everyone. Hello students. Closure distance of approach and kinetic relation is inverse relation. Impact parameter angle of scattering relation be proportional to cot theta by 2 relation. Number of scattered particles per the angle is 1 by sin to the power of 2 theta by 2. This is the question they will ask. Keep in mind. Yeah. So and conclusions of Rutherford model is important. So after this, now what are limitations of Rutherford model? Yes, no. So limitations of the third model is that, as you mentioned, bulk center portion is nucleus, electrons are revolving around the nucleus, okay, in circular orbits. We just able to explain only the neutrality of the atom we explain. Okay, in the electrons equal positive is there, positive how arrangement is there, electron revolving, he could able to explain. But other things he could not explain. What are the other things? Actually, according to classical model of electromagnetic wave theory, if you consider, as the electrons are revolving, as electrons are revolving, the direction of motion of electron is continuously changing or not? Yes, everyone. So direction is changing. See, velocity may be constant. As direction is continuously changing, so I can say velocity is changing. And velocity is vector coordinate. No, when velocity is changing, I can say particle is accelerating. Who is accelerating the particle here? Electrostatic force of attraction between these two accelerating the charged particle is provide necessary centripetal force. Therefore, electrostatic force of attraction between negative and positive charge providing necessary centripetal force. M is per R. So from here also question they may ask. This will be 1 by 4 by epsilon naught Q1 Q2. This is 2, if you can say any atomic number here, Z into E. Okay, by R square. This is equal to mv square by R. So from here you can find velocity and radius expressions. Yes or no? They are used for derivation regarding velocity of electron in a hydrogen atom, radius of the electron in hydrogen atom, kinetic energy of electron in the hydrogen atom, potential energy and total energy. These expressions are very important. So choose column. Now here, so as the electron is changing direction continuously, it is accelerating. The acceleration is towards center orbit, direction is reversing. Non-uniform acceleration. It's a non-uniform acceleration. By direction is continuously reversing, but pointing towards center. Okay, so fine. Now, whenever an accelerated charged particle emits what? An accelerated charged particle emits electromagnetic waves. This was found by Hertz scientists. Production of electromagnetic waves we have seen. Isn't it? So, when this particular accelerated charged particle emitting the what? Radiation, electromagnetic radiation, it is losing energy. So, it loses the energy. What happens? Slowly, it is losing the energy. Okay, and because of this attraction force and slowly, it is losing the energy. And what happens? Have a spiral-like structure and this electron will fall in the what? This particular nucleus and it has to collapse. Why? Electron and what? This particular positive charge equal and negative this could be neutralized by the atom stability was lost over here. Atomic stability was lost. This parameter was not explained by Rutherford. That means so Rutherford would able to explain partially. So what actually is not happening? Atom is what? Still electrons are revolving. Atom is stable. The stability was not only explained only by classical model. And one more thing, what happened? So these particular when the electron is losing the energy, continuously radiation is emitted. No? So we can if you pass by spectrometer, you get a spectrum, and this spectrum is continuous spectrum. Spectrum is what? Continuous spectrum. But at this time only, one school teacher called Balmer, so he discovered hydrogen spectrum. Okay, so hydrogen spectrum, Balmer series he discovered, and he showed that different lines in the Balmer series. So the spectrum is line spectrum. But according to the model, the spectra is coming as what? Continuous spectrum. This is contradiction. Therefore, he could not explain the stability of the atom and why electron revolving is continuously emitting. So continuous emission spectra he is saying, but actually emission spectra is not continuous. Emission spectra is discrete spectra. Spectra is what? Group of wavelength. When you emitted light, whatever it may be, when you pass it through, you will have what? So a group of wavelengths will frame in the photographic plane kind of thing. So on a white background, if you get dark line, that is called what? It is called Absorption spectra. And dark lines and a white background, what will you get? Absorption emission.
Emission.
White bright lines and dark background emission spectra. Light images. So white lights and the black background is called what? Emission spectra. If something is absorbed, that will be missing wavelength will appear as a dark line in the photographic emission spectra. Okay, that particular spectra is that is called absorption spectra. If see, you are sending light ray, a material, something is here, and transmitted light you are allowing to pass the spectrometer. So 4 wavelengths are there. Okay, one wavelength is being absorbed here. Only 3 wavelengths are going. 3 will appear as a bright. One will appear as what? Dark. That is called absorption spectra. Okay, so here continuous spectrum is giving, but strictly speaking, they are giving actually line spectra of hydrogen. So these things could not explain the stability of the what? Atom. Okay, and hence next scientist who came in the picture is Niels Bohr. 1912, 20th century. 1910, 1911, 12 our time lo. This Niels Bohr scientist, he come with a radical model. So by combining the early quantum mechanics concept with this classical concept, and he proposed a new model of the atom, which we call as Bohr atomic model. Okay, so Bohr atomic model. What are the postulates of Bohr atomic model? Everyone knows. Yes, right? What are the postulates of Bohr atomic model? So 3 postulates he made, no? So he proposed first the concept of what? Stationary orbits. Okay, concept of stationary orbit, discrete energies he proposed. Second one, so these stationary orbits are existing such that for each state of orbit, particular energy is there, no, such a way that their angular momentum is always conserved. Angular momentum is conserved. So for which energy levels angular momentum is conserved, such kind of discrete energy levels only exist and their energy is constant. Right? And third point we mentioned is that so transition happens. Why the explanation of discrete spectra is coming? Balmer series has showed that what discrete spectral lines are coming. That explanation was given that he mentioned that so in the atom, of course, nucleus is the electrons are revolving around circular orbit. Each value of discrete energy, energy E1, energy E2, he has given numbering also, and it is called principal quantum number. And he values will 1, this is 2, this is 3 energy levels and all. Okay, those energy levels we represent like this. Okay, from ground first level, second level, third level and all. This is equal, n is equal to 1, n is equal to 2, n is equal to 3, so on. So why the discrete spectra explanation? How he has given? When he said that electrons may also undergo transitions from one allowed energy level to another allowed energy level. What are allowed energy level? Allowed energy levels are those levels for whom angular momentum is constant. Such kind of levels only existing randomly. So, and when electrons are jumping from one to another, so they are emitting this photon. Okay, again it may come from here to here, or it may directly come from here to here. Different. So, when electrons are emitting, when electrons are re-exciting from one level to another level, difference in energy level is emitted as a photon, which is in the characteristic particular discrete line spectrum. Discrete what? Line spectrum. So E2 minus energy H mu, and this H is called what? Planck's constant. So like this, by using this quantum mechanics concept, early quantum mechanics concept proposed by Planck and Einstein. Okay, he proposed a new radical model, which we call Bohr's model, which is overcoming the limitations of Rutherford model. It is able to explain successfully stability, discrete energy levels, those for existing only from angular momentum is how much here is equal to constant conserved and this value is always integral multiple of what? H by 2 pi, where H is called Planck constant and the value of Planck constant everyone knows how much is 6.62 × 10⁻³ minus 34 joule second. Units are important. Okay, and then discrete energy levels because of this hydrogen spectra explains. Like this, certain extent what he could able to explain. But this particular atomic model proposed by Bohr was only able to explain successfully only single electron system, like hydrogenic or hydrogen atom. Hydrogenic and meaning lithium plus. Lithium is 3, no? Lithium plus means what? So plus 2, no? Then this is what similar to hydrogen atom. So he could able to explain only like hydrogen like atoms only he explained the atomic model. For higher electronic systems he could not explain. Okay, because of which we are nowadays understanding the atom so as a quantum mechanical system by using quantum mechanics principles we are trying to understand the atom. Okay, that is our discussion will go on. Bohr atomic model and hydrogen spectra will study. Our syllabus is limited for only what? Hydrogen spectra. Okay, right. Okay, ask on the points. 3 points: stationary orbits concept, conservation of angular momentum, discrete energy levels, and how he could able to overcome the limitations of Rutherford model. Next. So, and here when revolving around the electron and hydrogen atom, velocity, energy also important. Keep in mind. That also we'll see. Shall I go ahead? Hello, students.
Yes, sir.
తెలుసు సార్ అనవసరం చేస్తున్నారు ఇవాళ కావాలి రీజన్ కావాలి అంకిత కష్టమా Jitendra, where is your friends? Huh? Funny is there in the class? Funny, are you present in the class? Didn't come for the class, virtual class also? Yes, right? Yeah. So next we see about what? Something I'm saying? Yeah. Now, this is nucleus. Like now we focus only on hydrogen system, hydrogen like atoms. Okay, hydrogen atoms. So electrons, electrons. Electron is revolving around this one. Okay. So what is the force responsible here? This point is important. So electrostatic force of attraction is providing what? Necessary centrifugal force. So you can say mv square by r is equal to what you can write electrostatic force of attraction 1 by 4 by not q1 q2 q into q also e. If you take any other atom, you have to take what? Z here. Z into e you have to take. Okay. So e by what here? By r square. So this r get cancelled. So what is the r will be? R value how much rate? E square by 4 pi epsilon naught mv square. Okay, this is R value. R, if you want to find V value, velocity will be. Velocity V square is equal to E square by 4 pi epsilon naught mr. This is V square. I want V. V means root. Because how much now? E by root of 4 pi epsilon naught m into R. And one more beauty of Rutherford model is by using C point much more Rutherford model is nucleus now. So alpha particles coming here. This is the closer distance of approach now from this D and this alpha particle diameter and the size of the nucleus. Okay, this distance D is very larger than diameter of the alpha particle plus diameter of the what? Nucleus. So from these experiments, we conclude of the diameter of this nucleus, size of the nucleus is of the order of how much rate? 24 meters, 10 4 minus 15 meters. And size of this particular what? Atom, size of the atom is 10 4 minus 10 meters. So nearly million times larger the size of the atom than the nucleus. From this, we concluded that large amount of empty space is there between this particular nucleus and what? Atom size. Okay, this is the point. Size of the nucleus is expected by this Rutherford is of the order of 10 meters, 10 4 minus 15 meters. To some books also say 10 4 minus 14 meters. Size of the atom is how much? Atomic size is 10 4 minus 15 meters. This is nuclear size. Now, so this is velocity V is equal to E by root of 4 pi epsilon m into Rn. So this Rn value you can find from conservation of angular momentum principle here. But the conservation of angular momentum principle, second postulate of Bohr model. Yeah. So L is equal to mvr is equal to nh by 2p. Such kind of allowed energy levels existing for whom the angular momentum is integral multiple of h by 2 pi. N is equal to 1 first orbit, n is equal to second, n is equal to 3 third and all. So from this, for the value of r and will be radius of nth orbit. In that case, how much will have? This will be nh by 2 pi m into v. So now substitute the value over here. What we have? V is equal to root of E square by 4 pi epsilon naught m into Rn. Rn is nh by 2 pi m into velocity. This square is the velocity in this shade. Then what will have a value? So V proportional to we get n square by z and Rn proportional to z by n. This relation is important. I'm not going for derivations. So relations is important. What relations? How velocity. So for any atomic number like hydrogen atom like lithium is helium plus this or hydrogen atom is so z values V proportional to n square by z, R proportional to z by n. So from this time period and frequency of revolution they are asking sometimes. So here our time period T is equal to revolving, V is equal to d by T, T is equal to d by V. Time period proportional to d by V. Distance is proportional to what? Perimeter 2 pi r of the orbit. So 2 pi any nth orbit is 2 pi Rn divided by what is velocity? velocity proportional to what? L square by z. Some velocity. So T proportional to radius by velocity. T and proportional for time period is proportional to radius of the orbit by velocity. But radius proportional to what? Rn proportional to what? Z by n or n square by z ray. Just this one derivation part low. Don't do this mistake. Very important and compulsory. Write 2 times practice ray. Compulsory. Just a minute. I will the Rn proportional to n square to my knowledge. So Rn proportional to Rn proportional to n square by z. Rn proportional to n square by z. Vn proportional to z by n. Okay. V proportional to what? V proportional to z by n. Rn proportional to n square by z. Then time period of revolution of the electron in the orbit is time period depending on radius and velocity. Now, see here radius depending on what? N square value. So this is equal proportional to n square by z, and here v proportional to what, right? Z by n. Okay, for the same atom if we consider, atomic number is same here, isn't it? So what is the time period is proportional to n? Time period is proportional to what? N. What is n? Principal quantum number. Number of the that particular order of the orbit, and 1, 2, 3, so on. This point clear, everyone? So when you are deriving this one, be proportional to here, when we z r is equal to f. Here if you write 1 by 4 pi epsilon z e to e, if you write that will be involved in the velocity and radius. B proportional to z by l, Rn proportional to n square by z. Derivations we have done already. Okay. So the time period proportional to n. Frequency proportional to frequency and 1 by time period, n power minus 3. N power what? Minus 3. Okay, keep in mind this point. And then once you got the value here, so here V value in terms of E by 4 pi epsilon m into Rn. Okay, so from here Rn value is substitute, you will get the value of V. Okay, now if V, once you got the value of V, from the same expression you can find the value of Rn. Same expression, what do you find? Value of radius will find. Derivation is once go through it. Okay, and then now kinetic energy, potential energy is important. Now, this question once is asked in JEE mains. So when electron is what? De-exciting from higher orbit to lower orbits, what happens? Its velocity, kinetic energy, potential energy. What happens? So in an atom, an electron is jumping different orbits. So it is orbits, allowed energy levels are there. Here n is equal to 1, n is equal to 2, n is equal to 3, I don't know. Electron is de-excited. So it is coming here. What happens to potential energy, kinetic energy, and all is asked. So here we have just now we have seen what is velocity is important. Directly asked for data. And the electrostatic force is equal to centrifugal force now. So 1 by 4 pi epsilon naught q1 q2 by r square is equal to mv square by r. So this r will get cancelled. Mv square multiply with half, you get kinetic energy. So half mv square. If I multiply half, what will get it? E square divided by half is 8 pi epsilon naught into r. This is the kinetic energy. Kinetic energy is always positive. What is potential energy will be? Potential energy is what? 1 by 4 pi epsilon naught q1 q2. 1 by 4 pi epsilon q1. Okay, into q2. Charge of electron is negative. So into E by r. This will be minus E square by 4 pi epsilon r. This is potential energy. Yes or no? Potential is negative, kinetic energy is positive. Total energy is positive or negative? Total energy is positive or negative? Total energy is what? Negative. How much will you get total energy negative here? So total energy of the electron revolving in the nth orbit is potential plus kinetic. So potential is minus E square by 4 pi epsilon naught by Rn. You can take plus kinetic energy in the nth orbit is equal to given by E square by 8 E square by 8 pi epsilon Rn. Rn value already from conservation of angular momentum is found. We substitute that value, but total energy expression will get minus m to the power of 4 by 8 epsilon naught square n square h cube into c osula h cube osula minus m into the power of 4 by 8 epsilon naught square n square h cube. Okay. Now if I consider this energy, Okay, when I set the value of Planck's constant and electron value, mass of the electron, charge of the electron, I will get it minus 36.6 by m square. This will be in terms of electron volt. How much in terms of joule will be photon energy? Minus indicates that electron is bound to the nucleus by electrostatic force of attraction. Minus 13.6 by m square. And how much radius will you get? Length orbit radius is 0.53 m square Armstrong. 0.53 m square Armstrong. Okay, hydrogen atom, the radius of the nth Bohr orbit is equal to 0.53 m square Armstrong. Energy is minus 13.6 by n square electron volt. What is energy in joules? How much will you get? Minus energy in joules will be some minus 2.18 10 power minus 18 joules by n square. So 2.18 into energy in the joules. How much will you get, right? So 2.18 into 10 power minus 18 joules per n square. Okay, this electron volt energy term. Armstrong, this is in terms of joule. This also keep in mind. Sometimes for solving questions. Okay, this is what energy, radius, potential energy, kinetic energy, total energy of the electron. Now, so when the electron is de-exciting, so n value decreasing or increasing? Okay, spectrum you have seen hydrogen spectrum. If I consider level 1, level 2, level 3, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. Right? So now, what energy for first orbit? Minus 13.6. Second orbit, how much will be? 13.6 by 2. 2 square is 4. 4 3s are 12. 4 4s are minus 3.4. N is equal to 3, 9. So 9 ones are 9. How much left, right? 4. 9 5s are 45. Some minus 1.53 electron over something. So when electron is jumping from here to here and all, so in negative energy is what? Of course, negative is there. But value of energy, what is happening? Increasing. Energy, what is happening here? Increasing or not? So the relation is like photon energy, if you consider potential energy, if you consider kinetic energy, if you consider. Now, negative is common. Okay, velocity of electron V proportional to what, right? V proportional to Z by M. V proportional to what? Z by M. So for a given atom, as n value increasing, what happens? Velocity decreases. When n value decreases, what happens? Velocity increases. So when it de-exciting and coming to lower orbits, what happens in velocity? Increasing. When velocity is increasing, what happens? Kinetic energy also increases. Kinetic energy also increases. What is potential energy? Total energy is what? Constant, no? In particular, what happens now? Potential energy, what happens? So potential energy formula is what? Depending on what? Minus E square by 4 by epsilon naught into R. And in the orbit is Rn. But Rn value is what? Rn is proportional to n square by z. N square by z. Rn is n square by z. So inverse relation. N decreasing potential energy, what happens? Increases. So both potential energy and kinetic energy, what is happening there? Increasing also. But one point here. As kinetic energy is always positive. With n you get that. But here negative is the opposite to this one. Rn value proportional to n square by when n value decreasing, Rn is decreasing, and Rn is decreasing, potential is increasing, but negative property, potential energy decreases, kinetic energy what happens? Increases. So when electron is de-exciting, kinetic energy is increasing, potential energy what? Decreasing. Simple as. Is it okay, everyone? Fine. So total energy relation is potential energy or sometimes is asking. Okay, that also we'll see. So kinetic energy expression, how much we got, right? Kinetic energy, how much we got? Kinetic energy is equal to E square by 8 by epsilon R. And potential energy, how much? Of course, you have substitute the value of Rn. Rn value, how much, right? Everyone, remember Rn value? Rn ns by 2 pi. Sorry. N square h square epsilon by pi m z square astunana. Rn value. What is Rn value? Nth orbit is radius of nth orbit is how much? N square h square epsilon naught divided by, when you do the derivation, no, pi m z square. Pi m z square. Okay, that's why Rn proportional to n square by n z. Rn proportional n square z. N square z. Okay, so Rn is n square h square epsilon pi m z square. Okay, radius would be square. Now potential kinetic relation. Now we substitute the value here. Of course, both are common here. R are common property. When I write this is E square by 8. This is potential energy E square by 4. Yes or no? So can I write numerically potential energy by 2 is kinetic energy? Of course, only magnitude I am talking here. Numerically, the kinetic energy of electron nth orbit is half of the what? Potential energy. Yes or no? And total energy value how much you are? If we add these two also together, this is 1 by 4, 1 by 8 minus E square by 8 by epsilon naught Rn will be. So kinetic energy is E square by 8 by epsilon naught Rn. Total energy is minus E square. So this is also equal to total energy magnitude. So kinetic energy is half of the potential energy magnitude wise, and magnitude is numerically equal to total energy. Numerical. So based on this, so many times questions asked. Are you fine, everyone? Okay. So please focus on these points. So kinetic energy is numerically half the potential energy, numerically equal to total energy. Of course, total energy is negative, kinetic energy is always positive. Potential energy anyhow negative. Potential energy anyhow what? Negative. Okay. Keep in mind these points. Okay. Now hydrogen spectrum is all those energy levels. Okay. What is Balmer formula? Balmer series formula. What formula he has given? And you have to remember limit of series limit, maximum wavelength, minimum wavelength. After this, I will discuss that one. Once you got the energy value, minus 10 to the power of 4 by 8. This also important. Total energy expression. So many times the exam is asking. Minus 10 to the power of 4 by 8 epsilon naught square n square into h cube. Okay. Total energy expression. When you substitute the value of C in this expression, minus e square by 8 by epsilon Rn, no? Rn value how much? L square, H square, epsilon naught by pi m z square. We substitute over here. Then m L square, H square will go up. Okay. So by m is denominator, it also goes up. So minus pi m z to the power of 4 by it was the relation. Okay. When you substitute the value of what? Radius. When you substitute the value of radius, what the expression for energy is also important and cheptunna. Okay. Note it down. Puraga. Minus m to the power of 4 by 8 epsilon naught square n square h square. Not h cube here, I'm sorry. It will be h square. Rydberg constant h cube will see yourself. Okay. So here how much will get? Here will get h square only. Keep in mind. Minus m to the power of 4 by 8 epsilon naught square n square h square. Is total energy. Yeah. Next we'll see hydrogen spectra and excitation in different lines. Line spectra of hydrogen. And where you have to focus, I mentioned. Is it okay, everyone? Radius, velocity, kinetic energy, potential energy, total energy. In terms of electron volt as well as in terms of joules, you have to focus. In hydrogen spectra, first series was discovered by whom? By Balmer. So when the excitation and 1, 2, 3, 4. See, as n value increasing, the spectral line becomes closer and closer. Okay, and further after that, continuous spectrum is seen. No discrete spectra is seen as n values go on increasing. Okay, and moreover, the energy of electron is approaching towards zero. Approaching towards zero means electrons are free. Free electrons, they are no more bound to the nucleus. Okay, good this one. So now here, if I say n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. First series was discovered before hydrogen spectra proposed by Bohr and all this. Which scientist? That is Balmer. Okay, so Balmer series found that. So when entered, and he has given formula for that one. What is formula? Empirical formula Balmer gave 1 by lambda is equal to r into 1 by. He has given as 2 square minus 1 by n square. N starts from 3, 4, 5 square. And by giving different values of n value, he found the wavelengths. And the values of wavelengths also we listed out. Okay, 846.453 and 33.4 nanometers wavelengths he has given. Okay. Now, so here this R value, how much is R is called? Later we came to know this R value. He has given just a mathematics teacher. Okay, he related the wavelengths and he just designed a formula randomly. And this was coinciding with this energy calculation and all. Okay, therefore this R value is 1.097 into 10 power minus 7. Rydberg constant. What are the units of Rydberg constant? Right? Meter. per meter. What are the units of Rydberg constant? Yes, everyone. Per meter. What is the value here? 1 by lambda, no? This has no units. 1 by lambda is per meter only. Okay, 1.097 into 10 power minus 7. Minus or plus 7? Okay, mari jana mistakes only. Okay, so 1.097 into 10 power 7 per meter is the Rydberg constant. And when you calculate the energy expression E2 minus E1 is equal to h mu. From there, if you consider the wavelength and frequency how much? Mu is equal to C by lambda, multiply with C. C by lambda is equal to R into 1 by 2 square minus 1 by n square. Mu is equal to C by lambda. What is the value of energy we consider? This is frequency. What the energy of the emitted photon when the transition is happening here? Okay, h mu. So energy is equal to h into mu. H into mu. Mu means what? Mu r into 1 by 2 square minus 1 by n square. This is for energy of the photon emitted when the emission happens from any higher level to n is equal to 2 level. So it may be n is equal to 3 to 2, n is equal to 4 to 3, n is equal to 5 to 3. And if you consider this energy and frequency and wavelengths, no, all of they are lying in what region? Visible region. Visible region. So all of, we can see the spectrum region. Visible spectrum it is called. Okay, Balmer series lines are emission spectra lies in dash region. Which region? Visible region. Okay, keep it. So minus emitter for our this guy. And then when you calculate what's so different now from n is equal to 2 to n is equal to 1, you can say here now n is equal to 2 to 1 is equal to 1 and higher wavelength is lower frequency. Okay. And this is higher wavelength. This is called H alpha line of hydrogen, this is called H beta, this is called H gamma. Okay, H alpha line is equal to 3 to 2, H beta is equal to 4 to 2, H gamma is equal to 5, H gamma line you can use the letters. H alpha line, H beta line, H gamma line. And so the series which is coming, okay, the emission spectra of hydrogen, when the de-excitation of electron happens, from higher levels to n is equal to 1, ground level. So what you can call this one as n is equal to 2 to 1, n is equal to 3 to 1, n is equal to 4 to 1 and all. This is called what spectra? This is called Lyman spectra. Okay, Lyman spectra lies in what region? It lies in ultraviolet region. It lies in what region? Ultraviolet region. Technical. Okay, you should not misunderstand the words when I say something. See, misunderstand. Lyman LUV prema. Prema ante middle అందుకే చెప్తున్నాను. సో ప్రేమ ఎక్కడ ఉండదు? అన్నదమ్ముల మీద ప్రేమ ఉంటది, అక్కడి మీద ప్రేమ ఉంటది, అమ్మ మీద ప్రేమ ఉంటది, మన మీద ప్రేమ ఉంటది, అమ్మ నాన్న కదా. That is you understand. Remember love. So L stands for Lyman series, UV stands for ultraviolet region. Next, Balmer series. BV. हिंदी में BV बोलते क्या? That's not. हिंदी में BV को क्या बोलते पता है ना? Right? So remember like that. So remember the technical गुर्तिंచుకోవాలి తప్పదు. You cannot calculate and remember. No, full technical గుర్తుంచుకోవాలి. So Balmer series lies in what region? Visible region. Next, Lyman, Balmer. Next what right? N is equal to 3 to 1 na. Already Balmer over. Yeah, N is equal to 4 to 3 will come. Yeah, 4 to 3 will come. 4 to 3 will come. 5 to 3 will come. Or 6 to. Lyman, Balmer. Next what? Passion series. Yeah, Passion series what? IR region. Okay, yeah, visible అయిపోయింది, ultraviolet అయిపోయింది, infrared, far infrared is okay. Okay, now next, where is it increasing or decreasing? You see, this is visible. This is visible region. This is ultraviolet region. This is infrared. Wavelengths are decreasing. Why? Energy gap is increasing. Energy gap increasing, frequency increases. When frequency increases, wavelength decreases. So lower wavelength is what? It moves for infrared, far infrared, microwaves. Okay, na? Wavelength increasing, huh? Wavelength increasing, no? Wavelength is increasing. Frequency is first is Lyman, no? Ultraviolet. Ultraviolet, visible, wavelength increasing, man. series ila maatladane this series Lyman నుంచి మాట్లాడుతాను I am talking about Lyman to visible wavelength and comparing. Okay, passion. Next one, bracket. Bracket from where to where? 5 to 4, 6 to 4, 7 to 4. This is what? Lyman passion, and it's what? Bracket series. Okay. Next is what? Fun series. From 6 to 5, 7 to 5. Okay. This is what? Fun series. So keep in mind that there, once again before the NCERT textbook. So remember this regions in which the spectral lines are like. And formula, empirical formula, Balmer formula is this one. And in Balmer also sometimes wavelength they are asking. What is H alpha wavelength of the Balmer series? Up to H alpha N is equal to 3. N is equal to 3 to 2 is called H alpha. N is equal to 4 to 2 is called H beta. N is equal to 5 to 2 is called H gamma. H alpha, H beta, H gamma of Balmer series you have to remember. So if you want, I will give the values here, calculated values of a Balmer series, right? From 563 something also make it down. You have to calculate, there is no other way. Sometimes luckily if you ask directly, no, you can remember the values. Only for Balmer series you can remember, remaining you can calculate and tell. Did anyone remember the values of Balmer series? No. 453, 56 something at last time.
572.
Intrana? Yeah, I will give the values right here. Yeah, H alpha is 656.3. H alpha is 656.3 nanometers. H alpha is 656.3 nanometers, and H beta is 486.1 nanometer. 486.1 nanometer. This is blue green region. This is red region. Okay, and H gamma. H gamma transition from where? For H alpha transition from 3 to 2. For H beta 3 to 4 to 2. H gamma is 5 to 2. Okay, when you simplify this formula, Rydberg constant 1.097104, you know, and simplify for wavelength, then you get in terms of nanometers like this. So H gamma value is 434.1. 434.1. 434.9 lies in which region? Right? This lies in visible region. All are visible. This is violet, blue, green, and red. So all these wavelengths are lying in the region, visible region. So now general empirical formula by third postulates of Bohr, E2 minus E1 is equal to h mu. You can derive this formula of what frequency and wavelength. What is formula? General formula will get general formula of wave spectral line in case of hydrogen atomic structure, hydrogen like atom. Okay, this series is 1 by lambda is what formula? R into 1 by nf square minus 1 by ni square. So this for only single hydrogen. For any other, you are tried multiply with Z square. Hydrogenic like atom, like helium plus, lithium plus plus. Okay, so R Z square into 1 by nf square and 1 by ni square. Sometimes you may ask wavelength, sometimes frequency. Frequency is C, mu is equal to C by lambda. So multiply with C, we get frequency. Mu is equal to C by lambda. C is multiplied R Z square C into 1 by nf square minus 1 by ni square. Spectral line. Frequency. If you want energy is what? H mu. H multiplies H. This is R C Z square H into 1 by nf square minus 1 by n. Okay, so when you compare this one, okay, so here values are there for Lyman series. From where? NF final values they are coming in Lyman series. Final excitation to 1. So NF will be equal to 1 and NI will be anything from 2, 3, 4, 5 for Lyman series. For Balmer series, final value is 2. 1 by 2 square plus 1 by any value of n. That's why you get formula 1 by 2 square 1 by n square. For Lyman Balmer fraction, NF is 3. N may be more than anything 4, 5, 6 and all. Next bracket. What? NF is equal to 4, 5, 6, 7 like that. Okay, remember this formula also. And Rydberg constant value also in terms of ME, that M and all parameters important, right? That also remember also. What is the value of Rydberg constant here? Energy we have mentioned, no? h cube c వస్తుంది చెప్పండి చూడండి. m to the power of 4 by 8 epsilon equal constant value. m to the power of 4 by 8 epsilon naught square n square h cube into c. This square h cube into c. This is what equal constant. m to the power of 4 by 8 epsilon naught square ఎంతనా 8 epsilon naught square h cube into c. ఎందుకు స్క్వేర్ ఉంది ఇక్కడ మీకు r value we compare this with formula तो मैंने इनकम एनर्जी फॉर्म कंपेयर చేస్తే r value करना m to the power of 4 by 8 epsilon naught square h cube into c. Its value is 1.093 something in 10 power 7 per meter. Okay, these are the formulas. And one more point here they will ask is limit of the series. They will ask what is limit of the series? Maximum wavelength, minimum wavelength. Okay, it's called series limit we call. What do we call it? Series limit. Here things to be remembered are more, keep in mind. That's why you have to drill the session. You have to drill the formulas. That's important. Now, series limit. If I say Balmer series, if I say Balmer series में क्या हो रहा है? Radiation formula or spectral line formula 1 by lambda r into 1 by 2 square minus 1 by n square. Okay, for minimum wavelength, what should happen at minimum wavelength? Think about it. See, we have seen. So as the gap is increasing, energy difference also increasing. Okay, so if n is equal becomes infinity and is coming to n is equal to or n is equal to anything else, what is happening here? Energy gap is large. When energy gap is large, frequency is large. When frequency is large, wavelength is small. So shortest wavelength. Shortest wavelength. For shortest wavelength, n is what? N is equal to infinity to n is equal to any. If it is 2 Balmer series, if it is equal to 1 Lyman series, if it is equal to 3 Paschen series, like that. So series limit. So the minimum wavelength, energy gap will be large. Energy gap large, frequency is more. And frequency is more, wavelength is small. Shortest wavelength kavali ante in this formula of 1 by nf square. This is Balmer series fraction. So for any general formula I have to get. Our formula, general formula for shortest wavelength. In this formula, 1 by lambda is equal to r into 1 by nf square minus 1 by ni square. Ni initial, if this is becoming equal to infinity, if you want the shortest wavelength, make this n is equal to infinity. To any, if n is equal to Balmer series shortest wavelength will come. If n is equal to 3, Paschen will come. N is equal to 1, Lyman series. And highest wavelength means for this shortest, for longest wavelength longest wavelength రావాలంటే energy gap తక్కువ ఉండాలి. Energy gap తక్కువ ఉండాలంటే frequency తక్కువ ఉండాలి. When frequency is small means wavelength is large. If you want what highest wavelength, so energy gap must be small. Energy gap must be small means from immediate to next lower level it has to come. For Balmer series it is coming to 2, no? From 3 to 2 it has to come. Then it is the highest wavelength. So Lyman series highest one I want. From 2 to 1 it has to come. Therefore, for this longest wavelength, r into 1 by nf square minus 1 by ni square. No, ni value how much? Immediate this one. If I want Balmer series, this is 2, no? Not this is 3. If I have Lyman series, no? This is 1 means not take 2. Are understanding everyone? So keep in mind the shortest wavelength and longest wavelength also they are asking the question. Where you have to focus. Okay, right? Last one. Write one question. Yeah, anything left here? Right? Yeah. De Broglie explained matter waves and all lambda is equal to h by mv. Everything knows, you know. And de Broglie wavelength. Okay. See what is happening here. Material particles also has a wave nature he has mentioned. Of course, for macroscopic, the wavelength we cannot detect here. So then de Broglie wavelength of the what? Matter waves lambda is equal to h by mv. Higher is the mass, smaller is the wavelength. So, and we don't have any technique of measurement of smaller wavelengths. Therefore, we only consider de Broglie what wavelengths for microscopic particles, small atomic level particles only, like electron, proton, neutron, okay, all those particles we consider. So, like you can take a cricket ball with some velocity, you can calculate de Broglie wavelength, but that will become very very small. We cannot detect it, we cannot measure it. So, we are neglecting the de Broglie wavelengths of the microscopic particles. We are only applying for what microscopic atomic level constraints only we are applying de Broglie. H by P you can say. And which experiment has proved the discrete nature of the what energy levels in the atoms? Frank and Hertz experiment. Which experiment? Frank and Hertz, mercury vapors తీసుకుని they have sent the light and absorb spectra when the image no. So they found that discrete energy levels are existing. Which experiment has proved? Frank and Hertz experiment. Okay, keep in mind that also. In a multiple choice theoretical bits they may ask, right? Okay, and what else left in this now atomic physics now? And already in case of Bohr magnet I explained already the angular momentum is magnetic dipole moment of electron in the first Bohr orbit is called Bohr magnet. How much value I mentioned? 2.97 into 10 4 minus 27 ampere meters per second. Gurtunda? How much value? No one remember. You can just recall Bohr magnet value. Here they may ask in the atomic link చేయొచ్చు మీకు. Okay na? Endra value ఎంత? 9.27 into 10 power minus 10 power minus 24 ampere meter square. This is what Bohr magnet. What is Bohr magnet? Dipole moment of what? Dipole magnetic dipole moment of electron in the first orbit of the Bohr is called what? Bohr magnet. This point they are asking sometimes. This value how much by 2m? How much came? No, angular momentum. No, see, we have seen. Dipole moment vector how much was E by 2 much మనకి ఏదో చెప్తారా after we multiply with what EV by 2 or E by how much you got 2V or something came no E by that I into A no I is Q by T so Q means E P is 2 pi R by B so into area is pi R square. So after the zero just EVR by yes or no. So then you multiply and divide with what? M. So every R is called angular momentum. So magnetic dipole momentum is equal to 1 E by 2m into what? Angular momentum. In vector form it's constant, you write minus symbol. By both are in opposite directions. And L is equal to how much right? E by 2m. L value is every R. Every R value is NH by 2 pi. If I like L is equal to 1 and I simplify, how much value I am getting? How much are I getting? 9.27 into 10 power minus 24 ampere meters. Minus plus or minus chart చూడండి అక్కడ. That is very important, right? Remember the Bohr magneton value. How much will get? 9.28 10 power minus ఉంటుంది minus ఉంటుంది జాగ్రత్త చూసుకోండి. Bohr magnet is 9.27 or 9.28 into 10 power minus 24 ampere meter square. The magnetic dipole moment of the electron in the first orbit of the Bohr model is known as what? Is known as Bohr magneton. Is known as what? Bohr magneton. Okay, these are the points. Right, one problem now. So next we have expression later we will do. Discovery of neutron, size of nucleus and all these things. Right, one question, right? The wavelength of H alpha line, had a question. The wavelength of H alpha line in Balmer series of hydrogen atom is lambda. The wavelength of H alpha line in Balmer series of hydrogen atom. In Balmer series of hydrogen atom. The wavelength of H alpha line in Balmer series of hydrogen atom is lambda. Full stop. The wavelength of the same line in doubly ionized lithium is dash. The wavelength of the same line in doubly ionized lithium is dash. Yeah, what is the meaning of H alpha? In Balmer series, H alpha means what?
First line.
Isn't it? So in Balmer series means from n is equal to 2, n is equal to 3, n is equal to 4. 3 to 2 is called H alpha, 4 to 2 is called what? H beta. Balmer series 1 by lambda r into 1 by nf square. Nf is 2, I is anyone. So for H alpha line, 1 by lambda alpha is equal to r into 1 by 2 square minus 1 by. From where it has to come from alpha line? 3. 1 by 3 is 9. So this becomes r into 1 by lambda alpha for Balmer series. In case of hydrogen, is 1 by 4 minus 1 by 9. Delete. And but formula is comparing for what? Comparing for different atoms. So the formula 1 by lambda r into what should have here? Z square. Same H alpha saying H alpha in this value in the same, no? Delete. It's varying what? So 1 by lambda is proportional to what? Z square. Okay? So we can write our Z proportional to 1 by root lambda. Yes or no? Or lambda proportional to what now? 1 by z square. Lambda proportional to better red. Lambda proportional to 1 by z square. So in case of the lithium plus divided by lambda hydrogen is equal to inverse relation. No? What I will have here? Atomic number of the hydrogen by atomic number of what? Lithium. So hydrogen atomic number how much? 1. Lithium is what? 3. Whole square is 1 by 9. So therefore lambda lithium plus becomes lambda by 9 into lambda no. This lambda hydrogen. So H alpha and hydrogen is lambda. Same H alpha and lithium is how much? Lambda by 9. Same H alpha and hydrogen is how much? Lambda ite lithium length undi lambda by 9 avutundi. So don't forget this. Okay? Right. Write the question. The ratio of time taken. Listen over everyone. And you know excitation, potential energy, everything known, you know. Excitation potential means the amount of energy required to exert the electron from where? Ground level to what? Any other energy level. It's called excitation energy. Okay. Already we have seen minus 13.6. Next, what you have seen minus 3.4. Next minus 1.5 on radiation. Difference energy is what? Excitation energy. To any level you can take. Okay. Yeah. Next question down. Find the ratio of time taken. The ratio of time taken by the electron. Ratio of the time taken by the electron to go once round the nucleus. To go once round the nucleus in the orbits of radii. The ratio of time taken by the electron to go once round the nucleus in the orbits of radii r and 4r, capital R and capital 4r, r and 4r of hydrogen atom is dash. How much? Come on, tell me. Yes, all of you. See, second time revision is going on, which will be useful for boards as well as competitive exams we are doing. So, in the which Gadiva. Second answer, what you have seen? In hydrogen atom, okay, as you have seen, 4 hydrogen atom model, no? We have seen Rn proportional to n square by z. Velocity of electron in the nth orbit is proportional to z by n. Time taken to revolve any nth orbit of radius r, time taken is equal to v is equal to d by t, t is equal to d by v. Distance means perimeter 2 by Rn divided by Vn. What you have seen from this one? T proportional to Rn is proportional to n square by z. Vn is proportional to z by n. So T proportional to what? N cube by Z square. In the same atom, if you say Z is constant, so T proportional to what we are now? NQ. So from where to where you saying? From where to where you saying? R to R1 is equal to R2, R1 is equal to R2, R2 is equal to 4R. Now you have to get R and N relation. Because T depending on N here. So R and N relation, what relation? N proportional to root R. N proportional to what? Root R. Therefore, when it is root R, so T proportional to what? T proportional to N is root R. So root R whole power 3. So T proportional to R power 3 by 2. T proportional to what? R power 3 by 2. The ratio of time taken when you compare T1 by 2 is equal to R1 by R2. R1 is R, R2 is what? 4R whole power 3 by 2. So what you can write now? 1 by 2 square also 1 by 2 square whole power 3 by 2. Because 1 by 2 whole power 3 by 4. Yeah? 1 by 8. It's 1 by 8. 1 by 2 square. 1 by 2 whole square. 1 by 2 whole square, the power of infinity. 3 by 4. 2 to get cancelled, no? What do you have? 1 is to 8. R to 4R is 1 is to 8. 4R to R means 8 is to 1. According to order, remember. Let us see how to the question. And you know, energy, electron volt, and lambda. Everyone knows, no? Lambda, if you want, lambda in Angstrom is 12,400 divided by energy what? Electron volts, correct? Huh? On nanometer, 1240, 12,400, which is correct. Electron volts flow is 12,400. Electron volts, if lambda if you want in Angstrom, 12,400 by energy electron volts. E is equal to mu, U is equal to C by lambda. From there we have derived energy relation. So whenever you want lambda in the Angstrom, this one. And option number 1 by R value is 912 Angstrom. Sometimes the problem will be useful. 1 by R value how much? 912 angstroms. Keep in mind. Okay, everyone. Yeah. Right, one more question. What time now? Time no? So fine, that is basic questions on the series and theoretical bits. Simple calculations will be there. You need not to struggle much in case of this. Some memory based remembrance on the memory. Okay, so I'm sending some assignment also. You can go through it. The material or anything out. Sorry, no? So fine. Thank you all. This is about what? Bohr atom. One time revision. See, some point 1 or 2 may be missed, but you have to revise the entire thing. Already second time we are teaching the revision part. Okay? Yeah. Thank you all.